Hi, I'm Randall Heyman, a university mathematics academic. Welcome to my Corona Help playlists, where I make quick turnaround videos for educators and students during the coronavirus outbreak. If you'd like me to make a video for you, then just comment below any of my videos or drop me an email. Okay, this is part 2, or the second video for Subarata, who asked me to solve this recurrence relation with these initial conditions. And in the question, it actually said that to prove that this is the answer. Now, because we're given that final answer, I did in the previous video show you a sort of slightly cute way to satisfy, to answer the question properly. But in this case, what I'm going to do is I'm just going to write this to one side, and we're not actually going to use this in the question. We're just going to use it at the end to check that we got the right answer. So this is a very standard way now of solving the problem. Okay, so step 1, solve an minus 7an minus 1 plus 12an minus 2 equals 0. So you can see what I've done here. I've just ignored this 6 for the time being, and I've just put this term and this term on the other side, and so we get this. Okay, so how do we solve this? We have what's called the characteristic equation. And to do that, the an term just becomes lambda squared, and we go minus 7 lambda. And then the an minus 2 is just a constant, essentially 1. It's essentially lambda to the 0. So plus 12 equals 0. So we've turned the problem from a recurrence relation into just solving a quadratic, and therefore lambda minus 3, lambda minus 4 equals 0, and therefore lambda equals 3 or 4. So what we can say is this: we'll call it an, but it's not the final an. And what I'm going to do here is I put a little h, and that means homogeneous. This having 0 here makes this a homogeneous equation that we're trying to solve. And so the solution, because of this 3 and 4, we know the solution is going to be some constant a by 3 to the n plus some constant b times 4 to the n, and that will be it. So that's the first part. Okay, what's the second part? Now we have to solve for the 6. Remember, back here we have this 6 here. So I solve for the 6 to give, we'll call it a particular solution, which we'll label P for particular. Okay, so actually I've got a very good video on this called Recurrence Relations Made Easy, where I go through in some detail to get an insight into why these things work and the way I'm using them. So I know Subarata's had a look at that, but otherwise have a look at that video, because what this 6 tells us, it tells us that we should try to make this a constant c, where c is a constant. And what I mean by that, well, if that 6, instead of 6, had been something like n squared, well, there's a table I can read off which tells me what I should use. I should use cx plus d, cx squared plus dx plus c, I think, whatever. Anyway, have a look at the table in that video of mine, Recurrence Relation Made Easy, if you want to understand more why I picked, in this case, a constant. Okay, so if that's the case, so we're going to let P, A, N we'll let that equal C, and we'll let PAN minus 1 equal C, and we'll let PAN minus 2 equals C. Then, well, let's just go up. We're going to have to substitute this into, so what we'll now do is substitute it into this, or actually into this. Let me write that up properly. Then, so what I'm saying is AN minus 7, AN minus 1. That was at minus 12 or plus 12? I think it was plus 12 here. Plus 12 AN minus 1. What does that equal? Well, AN equals, so it's C minus 7 times C plus 12 times C, which is equal to 6C. So if we let 6C equal the 6, so this, the 6 is the right-hand side of the recurrence relation. Then C equals 1. So what that means is so this means that the particular solution equals 1. And so then, I suppose step 3, AN, which is what we want, is now just the homogeneous solution plus the particular solution. And so that was A times 3N plus B times 4N plus 1. So what this is sort of saying is that this bit, we've structured it so it equals 0. Well, it'll equal, yeah, no, I'm not going to explain that too well. Let's just stick to just following what we're doing. Okay, so now the fourth thing, and you must leave this till the end, is to solve for A and B. And let's just go back to the initial conditions. A1 equals 2, A2 equals 8. So we'll substitute these into, let's call this equation star. So all I'm trying to do here is work out A and B. So, well, we could say that A1 equals 2, but this is with n equals 1. So here I'm going n equals 1, n equals 1. So I'm just letting n equals 1. And what does that tell me? It tells me that A1 equals, which is equal to 2, because we're told that's what it equals. But now we can substitute it into this, equals A times 3 to the 1 plus B times 4 to the 1 plus 1. So therefore, 2 equals 3A plus 4B plus 1, and therefore 3A plus 4B equals 1. And then now let's do n equals 2. And, well, we know that A2 is equal to 8. So that it will be A times 3 squared plus B times 4 squared plus 1. And that tells us that 8 equals 9A plus 16B plus 1. And that tells us that 9A plus 16B equals 7. So now we've got two equations and two unknowns here. Let me just lower the screen a bit there. So here we've got equation 1 and equation 2. And you can work it out any way you want. I suppose what you could do is go 3 times equation 1. That'll give us a 9 here, minus equation 2. But I'll leave you to work it all out. I got here 4b equals 4, and therefore b equals 1. And once we've got b equals 1, we can then use, we could just then use equation 1. So we'll have 3a plus 4 times 1, because that's what we know what b is now, equals 1. And that tells us that a is equal to -1. Okay, so final answer. So now we know A and B. I'm just going to substitute it back into this here. So AN equals, final answer, I'll just put here, using star, will be AN equals, A is -1, so it's -3 to the n, plus B times 4 to the n, so that's plus 1 times 4 to the n, plus 1. And this is for, as it says in the question, n greater than or equal to 3. We already know what A1 and A2 are. Okay, so I hope that's helped Subarata, anyone else that's watching. If you've got any questions on mathematics in general, then comment me or email me. And if I think I can help you, I will try to do so.